All right. There we go. Okay. Now, one of the reasons that I kind of want to go, I really kind of want to make sure that you have a good idea about the bone tissue is because of how it affects all other tissues of the body. For example, if we think about the structure of the bone, okay? If we think about the structure, remember the cement portion is calcium phosphate. Let's say, for example, well, let me ask this question. Do you happen to know how levels of calcium are clinically significant? Like if levels of calcium are too high or too low. Do you happen to know how that shows up in a patient? Now, it will definitely, depending upon calcium intake, calcium buildup, calcium pull from the bone, it will actually affect density, which can be tested. You know, people can have bone density tests. But let's say that if a person's calcium levels were too high or too low, chances are, if it doesn't get regulated, they are going to end up calling EMT, getting to the emergency room, having the blood test done, because they're going to be suffering certain symptoms. Do you happen to know what they might be or how they manifest? Okay, remember, one of the things that the body's going to do, it is going to regulate calcium closely, because we're going to learn calcium is extremely important in muscle contraction, and calcium is extremely important in nerve conduction. So, and it sounds backwards, okay, but that's sort of how you can remember it. If calcium levels, let's say that too much of this is getting broken down, levels are too high in the blood, the people are going to actually be sluggish. All right? Their muscle movements are going to be slow. Their react time is going to be slow. Breathing is going to be... Now, note my different systems I'm including here. Breathing is going to be hard in labor. It's going to be slow. All right? Their heart beating is going to be slow. It could be so slow that it causes death. The reason for that, the calcium being too high in the blood, making this, basically it overstimulates the muscle and the nerve, all right? And they just can't react anymore. So therefore, that's one of the things that's important about calcium. If the calcium is too low, it's going to be overstimulated, okay? Muscles are going to be twitching. Heart's going to be racing. Once again, it could be to the point of death, okay? So this is just one example, just one, of how important bone's structure is, because of the fact that it will affect every system of the body, okay? So if we go back and if we think about this structure that we have right here, now remember, this is basically taking one of the long bones and looking like we took a cut out of it and gives us this, all right? So what we've got, if we had, you know, pieces and pieces here, okay, we would have this whole section of the bone. Now remember, straight down through the middle, what is this? What's this?
Sorry.
It's where we're going to find the bone marrow. Do you know what the name of it is? Going straight down through the middle. This part where this blood vessel is going straight down. Well, I guess I should. That is correct. Okay. But, Zach, I guess I should have been, rather than pointing to this one right here, which is the Haversian, okay, this one going straight down through the middle of the bone would be our central canal, okay? Now, remember that bone, you know, the last thing it is dry, okay? We've got this really good blood supply. Y'all remember the blood supply, okay? We've got a really good blood supply in the middle. Because if it's marrow, this is the point that we're making, let me rephrase that we are making blood cells, all right? Note my terminology, okay? I didn't identify which one, just blood cells. So, do you happen to remember what it's lined with? These little, well, first of all, what type of bone is this down through the middle? The spongy bone, all right? And what is it lined with? Now, hyaline cartilage is going to be important for this bone to grow, but this connective tissue wrapping, the endosteum, endo meaning in, okay? Now, if we begin to branch out, okay, do you happen to remember what each of these circles, these concentric layers are called? Like, what is this structure right here? The osteon, okay? This particular circle right here, this is an osteon. Do you remember what the lines of bone layers is called in between them? Well, these are concentric lamella, okay? So this is laid down, circle after circle. Each layer is a lamella, okay? But in between each of these circles, okay, there's like layers of bone that are just running straight. They are just a straight structure. Do you remember what that one's called? That one is interstitial, in between the cells, okay? Now, granted, interstitial, think of with the bone, in between. Do you remember what this one was? Running the circumferential lamella. Now, the wrapping that we see going all the way around, that is, of course, once again, a connective tissue wrapping. This time, what types of cells did it contain? Stem cells. Do you remember the name of them? Very good. Osteochondral progenitor cells. Osteo meaning bone, chondral meaning cartilage. Why do we need to have stem cells for both cartilage and bone in this connective tissue wrapping? Break a bone so it can repair. Also, that growth and development. Okay? Now, if we look at one of our osteons, this one right here with all these lines, one of them going one direction, one going the other direction. Do you remember what fibers that's supposed to be representing? The collagen fibers. Because remember, this cement getting laid down, the calcium phosphate, is around the collagen fibers. Having it go in one direction in one layer, the other direction in another layer, is giving it strength, and bone is very strong. Over here on this one, do you happen to remember what the little ants are representing? Osteocytes, all right? The mature bone cell. However, this cell that's trapped in the lacuna. All right, the little home. Okay. It has these little lines that are projecting from it. Do you happen to remember what those lines are referred to? The canaliculi. All right. They are projections because what does it allow them to do with the cells in the next layer? Communicate. And the communication is basically for passing of what? Nutrients and waste. Because right in the middle is our blood supply. All right? So, this structure, which is a good storage site. Now, we tend to think of bone as a storage site, for the calcium. Okay, got milk, storing it in the bone. There are other minerals in the body. Okay, we use magnesium, zinc, potassium. We have all of these other minerals, and they can get stored here too. Okay, but chances are we're getting them in such minute amount that the body's probably going to use them as we give it to the body. So this right here that we see, this is representing mature bone. This would be representative of a bone after growth has been reached fully, okay, and you're not growing anymore. That is pretty much the point that we are now at for today's lecture. Okay, so is everybody kind of with me at this point right here? Does anybody have any questions?
The canaliculi, what was that again?
Okay, the canaliculi. All right, see how we've got this osteocyte right here? We've got like one right here, one right here. And they're trying to show the little projection, the little squiggly lines. Okay, that is the canaliculi. And it would be connecting to squiggly lines to an osteocyte in this layer. And it would just continue to do that all the way up.
And you said that was supposed to communicate, or was it?
They're going to be able, because remember, bone is going to constantly be breaking down, building up, reshaping, all this sort of stuff, okay? And by having the supply to the blood supply, it can do that because it can build the bone. What cell came in and broke down bone? Do you remember? Osteoclast. Okay? The osteoclast will break it down. The osteoblast will build it up by laying down the calcium phosphate on the collagen fibers. And then, once it gets stuck in the matrix, it's the osteocyte. Pretty cool. Any questions?
Do the osteocytes communicate with the osteoblast and the class?
Yeah, with the osteoblast, okay, because that communication is going to be the one where this matrix, this hardened portion, is being laid down. So they do have a communication. And then when that cell gets stuck in the matrix, it'll still have the projection where it can talk to cells that are around it. Definitely not, a dead, dry tissue at all. Definitely a living, full of fluid tissue, for sure. Okay?